What lies at the very heart of our galaxy? It is a question that has haunted skywatchers for millennia, whispered in myths and painted in constellations, long before science gave the Milky Way its name. To ancient civilizations, the river of light stretching across the night sky was a bridge to eternity, a road of souls, a cosmic scar dividing heaven from earth.
Yet.
Behind its beauty lingered a mystery. The glowing band seemed endless, but what gave it shape? What secret force held its vast ocean of stars together? The first step toward an answer came when Galileo Galilei raised his telescope in 1610 and turned it toward the galactic plane. Where human eyes had once seen a hazy ribbon, Galileo saw a storm of countless suns, scattered like diamonds across black velvet. The Milky Way was no mist at all, but a swarm of stars, each one a distant sun, too faint for the naked eye to separate. A revelation unfolded. Humanity was adrift in a sea of stars, and somewhere in that sea, a center must exist. Centuries passed before the true scale of that center emerged. In the early 20th century, astronomers noticed that the Milky Way rotated as though bound to an invisible weight. The evidence grew stranger in 1932, when Carl Jansky detected radio waves streaming from the constellation Sagittarius. A hidden beacon pulsed from deep inside the galactic core. Later, Martin Schmidt and others traced stellar velocities that curved, bent, and accelerated around something colossal, something unseen. The evidence pointed to a hidden heart, darker and heavier than imagination could grasp. The center of the Milky Way was not empty space. It was a place where light faltered, where gravity ruled, and where the greatest mystery of our cosmic home awaited. At the center of the Milky Way, something strange was happening. Astronomers peering through the veil of interstellar dust noticed that stars near the galactic core were not moving as expected. They were not drifting slowly in wide arcs, as the mathematics of ordinary gravity would suggest. They were whipping around with ferocious speed, tracing orbits so tight and so rapid that only one conclusion seemed possible. Something massive, invisible, utterly unlike anything known must be there. The seeds of this revelation were planted in the second half of the 20th century, when technology advanced enough to pierce the dense shroud of dust and gas that obscures the galactic center from human eyes. Visible light could not escape the thick lanes of cosmic dust. But infrared light, with its longer wavelengths, could slip through. With new instruments mounted on some of the most powerful telescopes on Earth, astronomers began to unlock what had always been hidden. What they found defied comprehension. Stars in the constellation Sagittarius, especially those closest to a mysterious radio source, later named Sagittarius A*, were racing through space at thousands of kilometers per second. To put such velocity into perspective, the Earth orbits the Sun at about 30 kilometers per second. These stars were moving dozens of times faster, completing tight orbital paths in just a few short years. Gravity alone could explain this, but only if that gravity was produced by something immensely heavy, yet invisible. Among the scientists who devoted their lives to this enigma were Andrea Ghez at UCLA and Reinhard Genzel at the Max Planck Institute for extraterrestrial physics. On opposite sides of the Atlantic, two teams of astronomers began a decades-long endeavor to track the precise motions of individual stars, circling near the galactic heart, using adaptive optics and the penetrating eyes of infrared detectors. They followed these stars year after year. Among them was one particular star that would become legendary. Astronomers called it S2. About 15 times the mass of the Sun, it danced dangerously close to the hidden monster. Every 16 years, it completed a single orbit, swinging within just 17 light hours of the unseen core. In cosmic terms, this distance is barely a breath away. When S2 made its closest pass, its speed soared to more than 7,600 kilometers per second, nearly 3% the speed of light. No ordinary cluster of stars, no swarm of stellar remnants, no conceivable concentration of dark matter could explain such a gravitational grip. The math was inescapable. At the heart of the Milky Way resided an object 4 million times the mass of the Sun, compressed into a region smaller than the orbit of Mercury. The conclusion shook astronomy. It was not just an invisible mass, it was a black hole. For decades, the idea of black holes had been treated with skepticism, even by some of the greatest scientific minds. Born from the mathematics of Einstein's general relativity, they represented the ultimate triumph of gravity, a place where the known laws of physics break down, and where time and space are twisted beyond recognition. But many scientists believed that nature would somehow avoid creating such monstrous extremes. Perhaps the mathematics was correct, but the cosmos would surely have some safety valve that prevented real black holes from forming. The stars around Sagittarius A** proved otherwise. The evidence was overwhelming. The Milky Way had a supermassive black hole at its core, and if our galaxy contained one, then so too must billions of others. The universe itself was suddenly more terrifying and more wondrous than humanity had dared to believe. The emotional impact of this realization cannot be overstated. A black hole is not simply an astronomical curiosity. It is a region where gravity is so strong that even light cannot escape. To imagine one at the center of the very galaxy that gave birth to Earth and to humanity is to realize that our entire cosmic home revolves around an abyss. The discovery brought awe, but also unease. A black hole is not like a star or a planet that can be studied from a comfortable distance. It is a rift in reality, a reminder that the universe contains places where the familiar order dissolves into chaos. For the astronomers who tracked the dance of S2 and its neighbors, each new measurement confirmed a truth both exhilarating and humbling. They were gazing into a place where the cosmos keeps its most dangerous secrets as years of data accumulated. The orbits of dozens of stars were mapped with exquisite precision. Each one traced an invisible hand, pulling it inward. Each one whispered of the same dark presence. Together, they painted a portrait of the Milky Way's heart. The image was not of light, but of absence. Not of creation, but of consumption. Sagittarius. A** itself flickered with unpredictable flares of radiation, as if gas and dust falling toward the event horizon occasionally lit up in one last cry of energy before being swallowed forever. These outbursts added to the strangeness. The black hole seemed quiet compared to its cousins in other galaxies, far less voracious than the raging quasars that blaze at the edge of the observable universe. Yet even in its silence, it commanded absolute authority. The birth of this scientific shock did not end with confirmation. It opened new questions, each more haunting than the last. How did Sagittarius A** grow so massive? Did it form in the early universe and remain dormant, or did it consume stars and gas for billions of years until it reached its current size? Could there be more secrets lurking within the darkness? Other black holes spiraling nearby? Or even stranger forms of matter? For humanity, the revelation was like peering into the engine room of creation. The Milky Way, a spiral of hundreds of billions of stars, all turns around this single point of darkness. Our sun, our planets, every story of life on Earth orbit a cosmic abyss. In the grand narrative of the universe, the center is not a blazing beacon of light, but a silent, an invisible void. It was a shock not only of science, but of perspective. For centuries, people looked to the heavens and saw order, beauty, and divine geometry. Now, at the very core of that beauty lies a truth far more complex. The universe is not only a place of stars and light, it is a place where gravity reigns, supreme, where matter and energy can vanish beyond a horizon that no signal can cross. Andrea Ghez and Reinhard Genzel's teams, through decades of patient measurement, transformed an idea once relegated to mathematical speculation into an empirical reality. Their work earned them the 2020 Nobel Prize in Physics. Recognition not only of scientific achievement, but of humanity's confrontation with one of nature's most profound enigmas. The birth of this shock marked a turning point in our understanding of the cosmos. Black holes were no longer exotic possibilities. They were real, central, and inescapable. And in the case of the Milky Way, one of them was our anchor dot. As telescopes grew sharper and data more precise, the vision of Sagittarius A** came into ever clearer focus. Yet clarity did not bring comfort. Instead, it deepened the sense of mystery. To know that 4 million suns' worth of mass lies crushed into darkness is to confront a boundary where human reason begins to falter. The stars that orbit it continue their endless dance, oblivious to the awe they inspire. Their light carries across 26,000 light-years, reaching Earth as faint glimmers, tiny signals in the night sky. And in those signals lies a message that reshaped astronomy forever. At the center of our galaxy waits power beyond imagining. The discovery was not the end of the story. It was the beginning of a deeper descent into the unknown. Black holes are real, then so are their paradoxes. If Sagittarius A* exists, then so too does the challenge of understanding what happens inside. And if the Milky Way itself bows to the pull of this abyss, then humanity must accept that the heart of our home is not a source of light, but a prison of it. In this realization lies both fear and wonder. The birth of this shock was the birth of a new chapter in human knowledge. It told us that our galaxy carries within it a truth darker than myth, yet brighter than imagination. And it called us irresistibly to keep looking closer. The center of the Milky Way is hidden. To the naked eye, it appears only as a band of starlight stretching across the night. Dust clouds choke the view, scattering visible light, sealing away whatever lies at the galaxy's heart. For centuries, the veil seemed impenetrable, as though the universe itself wished to conceal its greatest secret. Yet with patience, technology, and unrelenting curiosity, astronomers began to craft new eyes, able to pierce the smoke and shadow of interstellar space. Infrared astronomy became the key. Unlike visible light, infrared waves can slip through dust and gas, carrying whispers from stars otherwise buried in obscurity. Instruments tuned to this hidden spectrum unveiled a celestial drama unfolding where human sight had long been blind. In the 1990s, the Keck Observatory in Hawaii, perched atop the ancient volcano Mauna Kea, used adaptive optics to strip away the blur of Earth's atmosphere. For the first time, astronomers traced the fiery dance of stars spiraling at impossible speeds around Sagittarius A*. On the other side of the world, in the Chilean desert, the European Southern Observatory's very large telescope pushed even further. 4 giant mirrors, each 8 meters across, worked in concert to achieve a resolution once thought unattainable from the surface of Earth. The VLT could not show the black hole itself, but it could track the orbits of stars with exquisite precision, watching them bend, accelerate, and twist under the crushing gravity of the unseen core. These orbits revealed not just the presence of a black hole, but the shape of its dominion, a well of space-time that swallowed all else into its pull. Yet even this was only a glimpse. It's the ultimate prize. The boundary where light itself falters remained beyond reach. To capture it required a telescope the size of Earth, and so the Event Horizon Telescope was born. Not a single instrument, but a global network of observatories linked by atomic clocks, stretching from Antarctica to Hawaii, from Spain to the South Pole. Together they formed an Earth-spanning eye, capable of resolving the shadow of a black hole's event horizon. In 2019, the EHT delivered its first triumph, the image of M87*, a black hole in a distant galaxy, glowing like a cosmic ember across 55 million light-years. But its second target was closer, far closer, the quiet giant at the Milky Way center. Imaging Sagittarius A* proved even more difficult. The black hole was smaller in apparent size, its flickering light shifting in minutes, like a candle flame in a storm. Still, the effort pressed onward, and in 2022 the shadow of Sagittarius A* was revealed. A dark void encircled by a halo of light, blurred by turbulence but undeniable. Humanity had looked into the abyss. The abyss had left its mark upon human imagination. The darkness, however, is never still. As telescopes gathered their measurements, they began to detect strange flickers, sudden flares of energy erupting from the galactic center. X-ray observatories like Chandra, orbiting high above the Earth's atmosphere, caught the bursts. Radio telescopes tuned to long wavelengths captured the echoes. Sagittarius A** was not silent, pulsed unpredictably, as though something within stirred and occasionally tore the fabric of its prison, spilling out energy across the cosmos. Each flare carried a mystery. Was it gas plunging toward the event horizon, heated to millions of degrees until it shone before its final fall? It magnetic fields twisting and snapping in storms of plasma, releasing bursts of radiation like solar flares, magnified beyond comprehension. Or could it be the remnants of stars shredded by tidal forces, their final embers flung into the void? No single explanation sufficed. The black hole flickered like a heartbeat, irregular yet persistent, a reminder that it was not dormant but alive with unseen processes. Around it, a maelstrom raged. Stellar winds from young massive stars poured torrents of gas toward the core. Clouds of hydrogen drifted into the region, colliding, compressing, sometimes igniting in bursts of star formation before succumbing to the black hole's hunger. Plasma storms twisted through magnetic fields, sculpting structures invisible to ordinary sight, but traced in the polarized light captured by radio telescopes. The center of the Milky Way was no quiet void. It was a battlefield, a place where creation and destruction coexisted in violent harmony. Astronomers began to piece together the rhythm of this chaos. They studied the orbits of stars not just to confirm the mass of Sagittarius A**, but to test Einstein's general relativity itself. When star S2 made its close pass in 2018, its light stretched and shifted under the influence of intense gravity. The observations matched Einstein's predictions precisely, even at the edge of a black hole's domain. Yet the confirmation only deepened the philosophical weight. If relativity held true here, then so too did its inescapable consequences. Within the event horizon, space-time collapsed into a singularity, point where the equations break and where human understanding fails. In this darkness, the Milky Way revealed both its heart and its paradox. For without the black hole, the galaxy's core would not be bound. Stars would not orbit with such precision. The spiral arms, stretched like cosmic rivers of starlight, would drift into disorder. Sagittarius A** is both destroyer and anchor. Its gravity tears apart gas clouds and stars, yet it holds the galaxy itself together. It is death and structure, silence and power. The flares observed by Chandra, by Keck, by the VLT are not random sparks. They are the final cries of matter at the edge of oblivion. Each one is a story of gas spiraling inward, compressed by gravity, heated until it glows, brighter than entire stars and then vanishing into silence. For a brief moment, the black hole reveals itself, not by its presence, but by the destruction it inflicts. Then the flare fades, and the abyss returns to quiet. Scientists speculate that one day, a larger feast may come. Perhaps a massive gas cloud will wander too close, igniting a storm of accretion that will transform Sagittarius A** into a blazing quasar, a beacon of energy visible across billions of light years. If that day arrives, the serene night skies of Earth would change. As the heart of our galaxy blazed with power unseen since its earliest days, for now, though, it waits, flickering, devouring in silence. The telescopes that stare into its depths are not only instruments of science, they are symbols of human longing to understand, to reach beyond the veil. Each observation is a step further into the labyrinth, a journey into the place where light dies and time bends. And so the story of Sagittarius A** grows deeper. No longer merely an unseen mass inferred from the motions of stars, it has become an object glimpsed in shadow, an active participant in the cosmic drama. The closer astronomers look, the more turbulent its portrait becomes. It is not just a black hole. It is a furnace of unpredictability, a storm of matter and radiation, a reminder that even in apparent stillness, the universe seethes with hidden fire. The darkness at the center of the Milky Way is no longer a mystery of existence alone. It is a mystery of behavior. What feeds it? What fuels its flares? What stories lie within the plasma and gas that spiral into its grip hall remain questions. Questions that drive telescopes to grow sharper, missions to aim higher, and imaginations to wander further. For in gazing deeper into the darkness, humanity has discovered not the end of inquiry, but the beginning of awe. The abyss at the center of our galaxy does not only consume matter, it consumes certainty. And in return, it offers the most powerful gift the cosmos can give: wonder. The deeper astronomers stared into the galactic abyss, the more unsettling the questions became. At the center of the Milky Way, Sagittarius A* loomed, its invisible mass confirmed, its existence undeniable. Yet the revelation was only the beginning. How could something so vast, so heavy, so ancient have come to be? And why did it remain so strangely quiet, when its cosmic cousins blazed across the heavens like lighthouses of destruction? Black holes are born in violence. When a star many times the mass of the sun collapses at the end of its life, gravity overcomes all resistance. Matter falls inward, light is trapped, and a stellar mass black hole is left behind. But Sagittarius A* was not the corpse of a single star. It carried within its darkness for millions solar masses. To grow so large, it must have consumed entire swaths of matter gas clouds, stars, perhaps even smaller black holes over billions of years. And yet if it had fed with such ferocity, why was it now so quiet? Across the universe, quasars offered a haunting comparison. These active galactic nuclei, powered by black holes billions of times the sun's mass, shine brighter than galaxies themselves. Streams of matter spiral into their hearts, heated into disks of unimaginable energy, producing jets of plasma that pierce intergalactic space. Quasars are the most luminous beacons known, visible from the dawn of cosmic time. In their light, astronomers witness the universe as it was billions of years ago, when galaxies were young and black holes feasted without restraint. By contrast, the Milky Way's central black hole lies in silence. Its accretion disk glows faintly, flaring only occasionally, its appetite curiously restrained. If Sagittarius A* once raged like a quasar, its fire has long since faded. The question remains, why? Did it gorge itself in the early universe, consuming until there was little left? Or is it simply waiting for its next great feast, slumbering until a passing cloud or star drifts too close? The mystery deepened in 2011, when astronomers discovered a strange object drifting towards Sagittarius A*. They called it G2. At first, it appeared to be a gas cloud, a loose, fragile veil of hydrogen falling toward the abyss. Predictions spread quickly. As G2 approached the black hole, it would surely be stretched, shredded, and consumed. The event promised to light up the galactic center, providing a rare chance to watch the feeding of a supermassive black hole in real time. But when G2 made its closest pass in 2014, something astonishing occurred. It survived. Instead of being torn apart and devoured, the object held together, slipping past the black hole's grasp with its structure largely intact. The event baffled scientists. Perhaps G2 was not a gas cloud at all, but the shrouded atmosphere of a star, or even a pair of stars locked in an intimate orbit, wrapped in dust. Whatever its true nature, G2 revealed that the galactic center held surprises still unimagined, and that predictions, even when rooted in the laws of physics, could falter against the universe's complexity. Other puzzles soon emerged. The stars orbiting near Sagittarius A* did not all move in neat, predictable paths. Some circled as expected, in elegant ellipses carved by the black hole's gravity. Others seemed to follow stranger patterns, inclinations tilted, orientations scattered, as though perturbed by hidden forces. The possibility arose that the central region harbored not only the supermassive black hole, but also other dark companions, perhaps smaller black holes, perhaps dense clusters of exotic matter. Their presence could warp the orbits of stars, tugging them into trajectories that defied simple models. If smaller black holes lurked near the center, they would tell a deeper story of galactic evolution. They might be remnants of ancient stellar deaths, drawn inward over billions of years, trapped in the gravity well of Sagittarius A*. Over time, some could merge with the central giant, feeding its growth. Others might remain in orbit, invisible, yet influential, a hidden swarm surrounding the abyss. The evidence for such companions remains elusive. Astronomers search for gravitational wave ripples in space-time produced when black holes collide, hoping to catch echoes of mergers within the galactic core. Future instruments like the Laser Interferometer Space Antenna, or LISA, may one day detect these whispers, confirming that the darkness at the Milky Way's heart is more crowded and more violent than it appears. The comparison with quasars casts a long shadow. Why is the Milky Way so different? Some suggest that our galaxy is merely in a quiet phase, its black holes starving for lack of fuel. In other galaxies, streams of gas pour continuously into the core, igniting torrents of radiation. In ours, perhaps stellar winds blow most material away before it can fall inward. Or perhaps by chance the Milky Way has simply been spared a recent merger with another galaxy, an event that would funnel rivers of matter toward the center. Awakening the slumbering beast, the silence of Sagittarius A*, may not last forever. A single collision, a single disruption in the galaxy's delicate balance could reignite it, transforming the gentle heart of the Milky Way into a quasar that outshines all its stars combined. The prospect is both terrifying and humbling. Humanity lives in a moment of cosmic quiet, unaware of what storms may yet awaken. Philosophically, the escalation of the mystery cuts deeper than astrophysical models. The black hole at the Milky Way's center is not only an anchor of gravity, it is a mirror of cosmic history, a witness to the galaxy's birth and growth. Its mass speaks of ancient feasts, of stars consumed, of collisions that shape the spiral arms we see today. Yet its silence speaks of restraint, of a balance on the edge of chaos. The orbits of stars, the survival of G2, the comparisons with quasars all weave a story of incompleteness. We know what Sagittarius A* is. We know its weight, its pull, its shadow. But we do not yet know its history, nor its future. Will it remain quiet for billions of years more? Or will it awaken in violence, changing the very character of the night sky? Astronomy lives in this tension between knowledge and uncertainty, between revelation and mystery. The escalation of the enigma does not end with answers. Each discovery brings sharper questions. Each observation peels back one veil only to reveal another dot at the heart of the Milky Way. Darkness waits. It is not the silence of nothingness, but the silence of something vast and unresolved. A silence that reminds humanity of its fragility and of its hunger to know. The stars still orbit, their motions precise yet unsettled. Flares still erupt, flickering like lanterns in the void. Clouds still drift, some destroyed, some surviving against all odds. Sagittarius A* remains a paradox, quiet yet powerful, hidden yet dominant, strained yet unfathomably vast. And as telescopes stare into its depths, one truth becomes clear. The more we learn of the galactic center, the stranger it becomes. The heart of the Milky Way does not yield its truth easily. What lies hidden in its darkness is not only an object of immense gravity, but a puzzle that stretches the limits of human imagination. Astronomers and physicists have tried to trace its origins, to understand how such a monster came into being. Each theory, each speculation, adds another layer to the enigma. One possibility is written in the history of galaxies themselves. Across the universe, galaxies collide and merge, drawn together by their mutual gravity. These mergers are not rare events, but fundamental steps in cosmic evolution. When two galaxies meet, their stars may pass each other without collision, but their gas clouds compress, ignite, and burst into furious waves of star formation. At their centers, the supermassive black holes they each harbor are drawn toward one another. Over millions of years, they spiral inward and merge, their masses combining into a larger, darker singularity. If the Milky Way has endured such encounters, then Sagittarius A* may be the heir, of ancient unions. A black hole forged through cosmic cannibalism, but mergers alone may not account for its present form. Theorists also consider the migration of intermediate mass black holes. These elusive objects, heavier than stellar remnants, but lighter than galactic giants, may form in dense star clusters. Over time, dynamical friction could draw them inward, toward the galactic center. One by one, they would merge with Sagittarius A*, feeding its growth and leaving behind faint signatures of their fall. If true, the Milky Way's central black hole is not only a relic of the early universe, but a mosaic of countless smaller deaths stitched together across eons. Yet even this vision may not tell the full story. The orbits of stars near the galactic center do not always follow simple patterns. Their eccentric paths raise the possibility that some unseen influence lurks there, something beyond ordinary matter. Dark matter, the mysterious substance that outweighs normal matter in the universe, could be shaping these motions. Though invisible to telescopes, dark matter reveals itself through gravity. If it clumps near the galactic center, it may warp the paths of stars, creating subtle deviations in their orbits. Detecting such effects could not only illuminate the nature of Sagittarius A*, but also provide clues to one of physics' greatest mysteries. What is the universe made of? At the heart of these questions lies the singularity itself, the theoretical point within a black hole where matter is compressed to infinite density. According to Einstein's general relativity, the singularity is unavoidable. Space-time curves inward without end, and the equations break. Gravity becomes absolute. Infinity is a signal, not a solution. It tells physicists that the theory, however successful elsewhere, cannot describe what truly happens in the deepest core of a black hole. To probe this region is to stretch relativity to its breaking point, to admit that another theory must one day replace or complete it. Quantum mechanics, the physics of the very small, may hold the key. Yet marrying quantum laws with gravity has proven one of the most difficult challenges in science. Stephen Hawking offered a glimpse of such a union with his prediction of Hawking radiation. Black holes, he argued, are not entirely black. Through quantum effects at the event horizon, they should slowly leak energy, emitting faint radiation until they eventually evaporate. For stellar black holes, this process would take far longer than the age of the universe. For Sagittarius A*, it would take longer still, yet the principle is profound. If Hawking radiation exists, then black holes are not eternal prisons. They decay, they fade, and their secrets may someday be revealed. But this raises the paradox of information. If a black hole evaporates, what happens to the information about the matter it swallowed? Does it vanish from the universe, breaking the laws of quantum mechanics? Or does it somehow emerge encoded in the radiation itself, hidden in ways not yet understood? The debate has raged for decades, drawing some of the greatest minds into its orbit. The answer, if found, could reshape not only black hole physics but the foundations of reality. Speculation pushes further still. Could the singularity at the heart of Sagittarius A* be more than a destructive endpoint? Some theorists imagine black holes as gateways. In certain solutions to Einstein's equations, a black hole may connect to a white hole, a theoretical object where matter and energy are expelled rather than consumed. In this vision, the black hole's singularity may not be the end, but a bridge, a passage to another region of space-time, perhaps even another universe. Such ideas remain unproven, bordering the edge of science and philosophy. Yet they remind us that the galactic center may not be only a place of annihilation. It may also be a place of creation, of transition, of hidden connections within the fabric of the cosmos. If the Milky Way's black hole is such a portal, then humanity lives in the shadow of a doorway, forever orbiting the unknown. These speculations reveal as much about human thought as they do about the universe. Faced with the abyss, the mind refuses to accept silence, seeks explanations, builds. Theories imagine structures beyond observation. Each hypothesis, galactic mergers, dark matter halos, Quantum evaporation becomes not only a model, but a story. It's an attempt to weave order into the darkness. The center of the Milky Way is thus more than an astronomical subject. It is a crucible of human curiosity. The questions it raises cut across physics, cosmology, and philosophy. How does a black hole grow? What holds the galaxy together? What happens to information, to time, to the very fabric of existence within the horizon? These are not questions with easy answers. They're the kind that linger, that demand patience, measured in decades and centuries, that stretch science toward its own event horizon. In the quiet flares of Sagittarius A*, the orbits of stars like S2, in the survival of clouds like G2, the hints are scattered. Each one is a clue, a fragment, a note in a cosmic symphony whose melody is not yet understood. The theories and speculations that arise are humanity's attempt to listen, to follow the rhythm, to anticipate the next movement, perhaps the greatest. Mystery is not whether the black hole is a portal, or whether dark matter shapes its domain, but why such questions matter so deeply to us. The abyss at the galaxy's center is far away, 26,000 light-years distant, yet it commands attention as though it were within reach. It is both alien and intimate, both terrifying and beautiful. It reminds us that our home, our solar system, our fragile planet, are bound to an invisible anchor. Orbiting in silence around a truth we barely comprehend, theories and speculations may change. Some will be confirmed, others discarded. But the wonder they inspire endures. For in imagining what lies beyond the veil, humanity affirms its own place in the cosmos not as masters, but as seekers forever drawn toward the darkness, forever hoping to glimpse the light hidden within it. To explore the heart of the Milky Way is to confront limits of sight, of precision, of human imagination itself. Yet again and again, science builds instruments that stretch those limits further. Each telescope, each detector is a vessel launched not into space, but into mystery, carrying human curiosity into realms that cannot be reached by eyes alone. The story of Sagittarius A** is therefore also the story of the tools forged to unveil it. Each one, a fragment of human ingenuity aimed at the darkness. The most dramatic of these efforts came in 2019, when the Event Horizon Telescope revealed the first image of a black hole. It was not the Milky Way's own, but a far greater monster in a galaxy called M87. Across 55 million light-years, a shadow emerged. A dark circle ringed by a halo of light, bent by gravity into an eerie crown. The image was blurred, imperfect, yet it was history. And for the first time, humanity had seen what had only been imagined. A black hole was no longer just mathematics. It was something that could be photographed. That triumph, however, was only a rehearsal. The true challenge lay closer to home. Sagittarius A** is smaller in apparent size than M87's black hole and far more restless. Where M87* changes over weeks, Sagittarius A** flickers and shifts in minutes. Capturing its shadow was like photographing a flame in a storm. The EHT turned its vast, earth-spanning eye toward the center of our galaxy, linking observatories from the South Pole to Hawaii, from Spain to Chile, and in 2022, after years of work, the image arrived. A ring of light encircling darkness, proof that the abyss at the heart of the Milky Way had finally been glimpsed. Yet even that triumph was not an ending. The EHT showed the outline, but not the detail. It offered a portrait, but not the processes within. To go further requires not only sharper images, but different senses altogether. For black holes do not speak only in light, they also speak in gravity, in the fabric of space-time. Collisions and spirals produce ripples, gravitational waves that travel across the cosmos at the speed of light. Detectors on Earth, such as LIGO and Virgo, have already heard the faint chirps of stellar mass, black holes merging in distant galaxies. But the great dances of supermassive black holes, the slow spirals near galactic centers, vibrate at lower frequencies, beyond the reach of ground-based instruments. To hear them will require a new kind of ear, floating not on Earth, but in space. The Laser Interferometer Space Antenna, or LISA, is planned as humanity's first space-based gravitational wave observatory. 3 spacecraft, flying millions of kilometers apart, will link their lasers in a triangle across the void. With this delicate web, LISA will be able to listen to the deep bass of the universe, the long, low waves of supermassive black holes. In motion, if smaller black holes orbit near Sagittarius A*, if mergers have occurred, or if stars are swallowed in spirals of destruction, their signals may one day be heard. The galactic center could become not just a sight to observe, but a song to record other instruments already orbit Earth, each offering a different window into the abyss. The Chandra X-ray Observatory, launched in 1999, has watched Sagittarius A* flare in sudden bursts of high-energy light. These outbursts, some 100 times brighter than its usual glow, reveal matter heated to millions of degrees before falling into silence. The flares are brief, sometimes lasting only an hour, but they are among the clearest signs that the black hole is not asleep, only patient. On the ground, radio telescopes like ALMA in the Chilean desert trace the cold gas swirling near the galactic center. Its arrays of dishes, spread across kilometers of desert floor, act as one vast ear, tuned 2-millimeter waves that reveal dust, plasma, the faint fingerprints of molecules in the chaos surrounding the black hole, where optical light is blind. ALMA listens, mapping the flow of matter into the abyss. Closer still. The gravity instrument at the Very Large Telescope has pushed the study of stars near Sagittarius A* into new precision. By combining the light from 4 giant mirrors, gravity achieves a resolution sharp enough to measure the tiniest wobbles in a star's orbit. With it, astronomers have seen the redshift of light from stars pulled by extreme gravity, confirming Einstein's predictions with exquisite clarity. Each orbit is a test of relativity, played out in the most extreme laboratory possible. And so far, Einstein still holds. But even Einstein may one day yield. The closer astronomers peer into Sagittarius A*, the more they edge toward the limits of general relativity. If deviations are ever found, light bends differently. If time stretches beyond prediction, it could signal the first glimpse of a new theory, one uniting gravity with quantum mechanics. The galactic center, then, is not only an object of astronomy, but the crucible for the next great leap in physics. On the horizon, the James Webb Space Telescope offers its own contribution. With its golden mirrors unfolding in silence beyond the moon's orbit, Webb peers deep into the infrared. Its eyes, sharper than any before, cut through the galactic dust with unprecedented clarity. Already it has begun to study the cores of distant galaxies, watching black holes feed and shape their hosts. In time, it may turn its gaze upon Sagittarius A*, unveiling the faint stars and gas clouds that circle ever closer to the edge of darkness, and beyond Webb other successors wait. In conception, telescopes that will see in X-rays with greater sharpness, and instruments that will map the polarization of light to trace magnetic fields near event horizons, arrays that will listen to the whispers of the universe with greater sensitivity. Each one will peel away another layer of the veil, bringing the invisible into view. Yet with each advance, new mysteries emerge. The image of Sagittarius A* was not the end of the search, but its escalation. The flares seen by Chandra remain unexplained. The orbits mapped by gravity still hint at hidden influences. The gravitational waves that LISA hopes to detect remain silent for now. Each tool answers questions, but each also sharpens the next riddle. The story of science at the galactic center is therefore not linear. It is recursive, spiraling, much like the stars around Sagittarius A* itself. Progress circles inward, each orbit bringing clarity, yet each orbit also raising the stakes. The closer we come to understanding, the more profound the questions become. For what lies at stake is not only the history of a single black hole, but the nature of reality itself. To watch Sagittarius A* is to test the boundaries of gravity, the laws of light, the fate of matter, the flow of time. It is to confront whether relativity is the final word, or whether a deeper framework waits to be discovered. And in this pursuit, Every telescope, every detector, every mission becomes more than an instrument. It becomes a bridge between ignorance and knowledge, between awe and explanation, between the human mind and the cosmos it inhabits. The future of this search is uncertain. Lisa may hear the rumble of unseen mergers. It may reveal stars yet unseen. Successors to the EHT may capture movies of the black hole's flickering shadow, showing not just an image but the motion of matter falling inward. Each possibility is a doorway, and behind each doorway waits another corridor of mystery. And so, even as the scientific tools sharpen, the essence remains the same. The center of the Milky Way is not a problem to be solved, but a frontier to be approached. Its silence, its flares, its shadow, they are not final answers, but invitations. Invitations to build, to imagine, to listen more deeply to the cosmos. The investigations continue, and with them, the mystery only grows. For at the heart of the galaxy, science does not simply describe, it reaches. It reaches into the unknown. Armed with mirrors, antennas, and lasers stretched across space, it reaches not to conquer the darkness, but to dwell within it, to hear its voice, to translate its silence into understanding. And perhaps, in the end, this is the truest role of science. It's not to strip the universe of wonder, but to make its wonder visible, to take the hidden and bring it into human sight, to let the abyss at the galactic center, in all its darkness and turbulence, speak. At the heart of the Milky Way lies a paradox. It is a place of unimaginable destruction, where stars are torn apart, where light itself is swallowed, and where time bends into shapes the human mind struggles to conceive. Yet it is also the anchor of our galaxy, the gravitational keystone that binds the spiral arms and steadies the dance of hundreds of billions of stars. Without it, the Milky Way as we know it would unravel. The abyss is both predator and foundation. In its violence lies necessity. In its silence lies order. The dual nature of the galactic center echoes through philosophy as much as through physics. Black holes are not merely celestial objects. They are symbols of endings and beginnings, of dissolution and rebirth. In their shadows lies the ultimate destruction of matter and memory, but also the seeds of new creation. The gas clouds that fall into Sagittarius A** are not only consumed, they're friction and fire-seed bursts of energy that ignite new stars. Breathing fresh light into the galaxy, death feeds birth. The abyss gives rise to brilliance. For humanity, staring into this paradox is an act of recognition. The black hole is not only a cosmic reality, but a mirror. In its depths we see our own contradictions, our fragility, our curiosity, our endless hunger to understand. Like the stars orbiting at the edge of its horizon, we circle mysteries we cannot yet penetrate. We know the danger, yet we are drawn closer, compelled not by